Welcome to Brain Vision.
So in the problem, we have the wave height function h, which depends on the wind speed v and duration t. So the values of h are given on a table of values. And here we only have, or I only show the values of h which are important to our computation. So the first problem is to find the value of h when v equals 40 and t equals 20. So looking at the table, when v equals 40, we look at this row, and when t equals 20, we look at this column. So it is clear that the value of h at v equals 40 and t equals 20, it's equal to 28. For the second question, we want to find the value of h when v equals 43 and t equals 24. So looking at the table here, there are no v equals 43 nor t equals 24. So we can only approximate the value of h, which is f of 43, 24, via the linearization capital L of 43, 24. And this linearization is given by the formula f of ab plus f sub v of ab times 43 minus a plus f sub t of AB times 24 minus B. Here, A is a wind speed, B is a duration. Keep in mind that to be successful, our A must be close enough to 43 and B must be close enough to 24. The next part of the solution is divided into three steps. First, we want to find the values of A and B. Then we need to find the first partial derivatives of f evaluated at AB. And then finally, calculate the final answer. So for the first step, we want to find AB. And here, we want our A to be close enough to 43. And 43 is between 40 and 50. And 43 is closer to 40 than to 50, so we take A equals 40. For B, we want our B to be close enough to 24, and 24 is between 20 and 30, and 24 is closer to 20 than to 30, so we take B equals 20. So, substituting these values, we now have the following linearization. So f of 43, 24 is approximately 28 plus 3 times f sub v of 40, 20 plus 4 times f sub t of 40, 20. So 28 here, it's the value of f at 40, 20. 3 here came from 43 minus a, so 43 minus 40, which is 3. And 4 here came from 24 minus b, and b equals 20, so 24 minus 20. For the next step, we want to find the partial derivatives of f evaluated at 40, 20. So, for instance, we have f sub v of 40, 20. We recall the definition. So it is the limit as delta v goes to 0 of f of 40 plus delta v, 20 minus f of 40, 20 divided by delta v. Now, since we don't have any explicit expression for h, we can only approximate the partial derivatives using the table. So the intermediate numbers from 40, looking at the table, are 30 and 50, and both of these are 10 units away from 40, so we can take delta V to be 10 or negative 10. For delta V equals 10, f sub V of 40, 20 is approximately equal to f of 50, 20 minus f of 40, 20 divided by 10. And f of 50, so f of 50, 20, looking at this row 50 and looking at the column 20 here. So f of 50, 20, that's equal to 40. and minus 28 divided by 10, this is equal to 1.2. For delta V equals negative 10, f sub V of 40, 20 is also approximately equal to f of 30, 20 minus f of 40, 20 divided by negative 10. And looking at the table again, we will obtain 17 minus 28 divided by negative 10, which is equal to 1.1. And following the solution in the example and the textbook, this f sub v of 40, 20 will be approximately equal to the average of these two values. And the average of these two values is equal to 1.15. For the other partial derivative, f sub t of 40, 20, so we recall again the definition, limit as delta t goes to 0 of f of 40, 20 plus delta t minus f of 40, 20 divided by delta t. And looking at the immediate numbers from 20, we have 15 and 30. So we take our delta t to be 10 and negative 5. When delta t equals 10, f sub t of 40, 20 is approximately f of 40, 30 minus f of 40, 20 divided by 10. And looking at the table again, we have 31 minus 28 divided by 10, which is equal to 0.3. When delta t equals negative 5, f sub t of 40, 20 is approximately f of 40, 15 minus f of 40, 20 divided by negative 5. And using the values on the table, this is 25 minus 28 divided by negative 5, which is 0.6. And again, f sub t of 40, 20 is approximately the average of these two values, which is equal to 0.45. So substituting the values that we have, f of 43, 24 is approximately 28 plus 3 times 1.15 plus 4 times 0.45, and this is 33.25, meaning h is approximately 33.25 when v equals 43 and t equals 24.